Alright, in this lesson we're going to take a look at ionic bonds. And so the book starts out by giving an example of how you have a total of 45 cents and your friend also has a total of 45 cents. And your friend is interested in getting a pear, which is priced out at 50 cents. And you're okay with getting an apple, which is priced out at 40 cents. So you and your friend talk, and you come to the agreement that if you give up a nickel to your friend, that person is now going to have 50 cents, which will allow them to get the pear, which is priced out at 50 cents. And just by subtracting the 5 cents off, you're still going to have enough money to be able to get you an apple. And in a roundabout way, this is what ionic bonding is doing. It's where one atom is going to give up its electron to another atom to make sure they get what they want. And so in return, both atoms are getting what they want. So let's take a look at what all of this means. So to start with, we know that valence electrons are the electrons that are furthest away from the nucleus. And so if there are valence electrons of 1 and 2 and 3, we know that they are going to have not close to having the octet rule completed. And what we mean by the octet rule, and I'll draw an octagon here, is the fact that we are going to have 8 seats, and what we talked about is we compared it to a lunchroom table. So if you have 1 seat and 2 seats and 3 seats and 4 seats, 5, 6, 7, and 8, what we know is that if you have one person sitting at the table, you're not real close to having it completely filled. So one valence electron is going to mean that there's 7 open seats at the table. If there's a second valence, so you have 2 valence electrons, it means that there's 6 spots that are open at the table. And if you have another valence electron, so you have 3 total, now you have 5 seats. And so what happens is because they're so far away from completing the octet rule of having 8 at the table, these electrons are going to leave and go to the other atom. And we said in class that it's a positive thing for them to give off their electrons. And so they will always take on the positive charge. And it's whatever number that they're giving up. And so if it's 1 valence electron, it would be a positive 1. If there's 2 valence electrons, it means that there's going to be a positive 2 charge. If there's 3 valence electrons, it's a positive 3 charge. So we always go through and give it the positive charge. So for example, if we look at sodium, sodium has 1 valence electron, which means that it has 7 spots that are open, so it's going to give up that 1 valence electron, so this is going to have a positive 1 charge. So if we take a look at the other numbers that are over here, so we know that you can have 5, 6, 7 valence electrons. So if we draw our table again, now what we have going on is still having our 8 seats at the table to complete the octet rule. But now this time you could have 5 people sitting at the table, so 1, 2, 3, 4, 5. Now it's much closer to being filled up. Or you could have 6 people, so now there's only 2 spots that are open for 6 people at the table, or in this case 6 valence electrons, or 7, which means that it's only 1. And so it's going to be a lot easier for atoms that have 5, 6, or 7 valence electrons to attract another electron or 2 or 3. And so because they're kind of stealing away somebody else's electrons, what we do is we say that's a negative thing. And so anytime that they have valence electrons of 5, 6, or 7, it's going to have a negative charge. So for example, chlorine has 7 valence electrons, so it is going to be 1 short of completing the octet rule, so we know that it has 7 valence electrons, so it takes on a negative charge. And now this time what we do is we look and see how many that it is short of completing the octet rule. So in this case it would be -1. And so what we did is we're actually creating ions. Each one of these is an ion, and an ion by definition is going to be an atom or group of atoms that have an electric charge. And by electric charge, what we're referring to is going to be that they take on this positive or negative role. All right? And so that is an ion. And so this would be a positive 1 ion, this would be a negative 1 ion. Now, sometimes what happens is that we have atoms that actually have a group of atoms together. So, for example, you might have something like a carbonate ion. So carbonate has a CO3 with a negative 2 charge on it, and so what we would call this would be a polyatomic ion. And so this is an example of that. So again, all we have going on here is you have a group of atoms that are occurring. All right, so that's an example of that. Now, what we know is that there are things that are called ionic bonds, which was what the start of this is all about, which means that you are going to have a definition. So an ionic bond is where you have an attraction between two opposite charged ions. All right, and so let's take a look at this. If you have, for example, let's take magnesium, and magnesium has a valence electron of 2, so it has 2, and from that previous slide that I had shown, it tells us that we have 2 valence electrons, which means it's going to be positive, so it's easier to give up those 2, and it's going to have a positive 2 charge on it. And so what happens is that there's an attraction between this positive charge and a negative charge. So if we take chlorine, for example, and we draw in our dot diagram, we know that this has a negative 1 charge on it. And so that attraction between the positive and the negative is what creates this ionic bond. But as we talked about in class, on the number line, what happens is that if you have a positive 2 charge, so it's starting out right here, and we have a negative 1, it's going to back us up 1 spot. We're still not at 0, which is where we want to be. So how do we get back to 0? And the way we do that is by doubling the amount of chlorine that we have. And so what we would do is we'd have another chlorine atom. So we'd have Cl 1, 2, 3, 4, 5, 6, 7, which has a negative 1 charge on it. And so what happens is that these electrons will go to their spots, which is going to create a bond that's going to exist. And so we'd actually write this as being MgCl2. And this entire thing is called a chemical formula. Okay, so chemical formula. And more specifically, when you look at some of the parts of this, this is what we call a subscript. Okay, so a subscript is going to be a ratio of elements. So it tells us that there is magnesium because you have a capital and a lowercase, so that means these two are together. And you have a capital and a lowercase, so this is capital C, lowercase l, and it has 2 chlorine atoms, so it takes 2 chlorine atoms to bond together. So this whole thing is called the chemical formula. This is called the subscript because it's telling us how many that there are of it. So once we have negative 1 and negative 1 together, that makes 0 when it's applied to the positive 1. Alright, so structurally, which we talked about in class, we know that you'd have to have M G with a single bond to chlorine, and so this is going to have a negative. We can just make it negative, and this is a positive charge, so you can say negative, and a single bond over here to chlorine, which is going to also have a negative bond. And so this would, this bond that would exist right here is going to have that negative charge to it. And so the electrons are being shared, or this magnesium is giving it up to the chlorine so that way they can attach at the single bond. And the same thing is happening with this chlorine, which is going to accept that one valence electron. And so the magnesium gets wedged in between these two as it bonds together. And so the other thing that we had talked about in class and we did a lab with are the properties of ionic bonds. So, of ionic bonds are going to be the following. The first one is that they are oftentimes hard and brittle. So when we look at the texture of it, it's going to be oftentimes difficult to break, and it's going to be the property is going to be oftentimes hard and brittle, which means that it's going to be easy enough to break apart, so it's brittle, but when you first look at the appearance of it, it's going to have a composition that is hard. The second thing about them is that they all have high melting points. High melting points. So it's going to take a lot of energy to break these apart. And the third one about them is that it is going to dissolve in water, or when they do melt, that they are going to conduct electricity. And so when they go through that process, we learn that they have a conductivity, which we use the reader to be able to look at and figure out which one has the ability to conduct more electricity. So those are the properties of ionic bonds. And so go ahead, fill out the form, and if you have questions, make sure you add them to your summary. And if you have other questions, feel free to email me or let me know in class. All right, talk to you later.